Good morning, everyone. My name is Ming Chi, and today I will be introducing my InvenTech project, the Edge AI soil monitoring system for Durand Rural. To understand why the system is necessary, we must first look at the economic landscape. The global market value for Durand is massive, which is sitting at approximately 7.31 billion USD in a year, and the premium variety has created a multi-billion ringgit export industry in Malaysia, especially the Musang King and Blackthorn, and this has successfully to help us to transform the small village to large-scale commercial estate. However, the farmer faced a devastating crisis. A disease, a pathogen called Phytophthora parmivora. The disease causes the root rot to the tree and that can kill the tree within a few months, which leading to multi-year losses, and up to 40% yield loss has reported in infected orchard. This is the durian that infected by the disease. This is a sample. And there's some challenges that are faced by the farmer in a real world. So the first challenges, the main challenges that faced by the farmer is the late detection. The symptom of the disease only became visible when several root damage has already occurred. And the traditional lab testing for the disease is slow and costly. And the standard cloud-based IoT solution often fail in the rural orchard because the lack reliable internet access, which is the connectivity issue. So to solve this, I developed a proactive edge AI solution that brings intelligent directly to the field. This enables real-time local prediction without needing cloud connectivity. So let me talk to you how the hardware is built. A low-cost ESP32 microcontroller acts as the brain of the whole setup. It gathers continuous data from a specific suite of sensors, two capacitive moisture sensor monitoring both the surface and the deep root zone, a pH sensor which tracking the soil pH level, and a temperature sensor tracking soil condition, the temperature. Because this system is designed to be a deploy and forget tool for remote orchard, is entirely self-sustaining. The power system runs on a solar panel connected to the solar charge controller. To ensure the stability, the controller is wired with a GSBMS board, which then regulate the battery output to safely charge on the battery and power the IoT device. Next is how the system works. The sensor continuously collect the deep soil moisture and the soil surface moisture, pH level, and temperature data. All of this is transmitted directly to the ESP32 microcontroller. Instead of trying to push this raw data to the cloud over a weak signal area, the ESP32 runs an edge AI model, specifically a quantized tiny machine learning model is implemented directly to the device. This model instantly analyzes the data pattern for root rot risk condition right at the source as shown in the diagram. Yep, this one. The AI classifies the risk into three levels: class 0, class 1, and class 2, which represent the low risk, medium risk, and high risk. And emergencies will state the trigger immediately notification. So when a risk is detected, a real-time alert are sent out via an onboard display and wireless notifications such as email and apps notification. Meanwhile, all the data is collected and recorded for historical review. You can check back the history at night or in the past few days as an example and so on. So in conclusion, by analyzing the complex environmental data on device, this quantized tiny machine learning achieved an impressive 95.59% predictive accuracy, and it successfully shifted orchard management from reactive visual check to early subterranean monitoring by sending instant alert to prevent the root damage before the symptom ever appears. Also, a low-cost ESP32 setup helped the farmer to eliminate the expensive lab fee. Next, the system is successfully implemented and proved that the self-sustaining of the system in real orchard is good and nice after experiment. So before I end up all this, I would like to express my deepest gratitude to my supervisor, Prof. Chiang Kai-yong, for his invaluable guidance in organizing this project. I also want to thank him and Multimedia University for providing providing me this opportunity to participate in the competition. Thank you all for listening and welcome any question about the project. That's all from me. Thank you.